first of all, this question is nicer because we don't have to define it. So in each of these questions, I'm going to put a green box around the ending here, and they have already given us where it's defined. So in the previous question, it asked us to say where it was defined. Okay, here, this isn't part of the question, but they've already defined things for us. They said n and m must be bigger than or equal to 0. So when we get to part A, it's just a matter of, can we add and subtract like terms? This one is already in simplest form. They're already mixed radicals. Inside the square root is nothing else that we can simplify. These two are like terms, and these two are like terms. So 7 root m's minus 3 root m's would give me 4 root m's, and 2 root n's plus 5 root n's would give me 7 root n's. So this would be my final answer for part A. Comparing and putting like terms together is already done. Same thing in part B. Part B is nice. If I look inside, there is nothing I can do to simplify. Well, theoretically, there might be one little thing, but we're going to ignore it. Technically, with the cube root of -1 is -1. You could bring out the negative out in front if you wanted to, but we're not going to worry about that. We're going to just say there's no numbers I can pull out, no variables I can pull out inside either my cube roots or my square roots. But I have to notice that in order for them to be like terms, not only does the inside have to be the same, but the index has to be the same as well. So those two are like terms, and these two are like terms. So putting the purple ones together, I have 2 cube roots minus 9 cube roots. That'll give me -7 cube roots of -3b. And then 8 square roots plus 3 square roots will give me plus 11 square roots of -3b. Okay? Now, if this was a multiple choice, I'm going to just write 4, and then I'm going to put in brackets, since the cube root of -1 is equal to -1, because this could happen on a multiple choice. You're doing a multiple choice question, you get the answer that we've written right there. You look at all 4 multiple choice answers and none of them match because they've done this. The cube root of a negative is a negative on the outside, so that means I could change this first one, pull the negative out, and make that +7 cube root of +3b plus 11 square root of -3b. Now, the answer at the bottom of your page, they didn't simplify that all the way, but I do want to show you those things so that if this did come up on a multiple choice question, you're not like, the answer's not there. Well, there might have still been some simplifying that you could do. Generally speaking, from a textbook or a mathematician's point of view, if they have a negative inside, they would probably like to pull it out. The more negatives you can get rid of, usually in a question, that's better for you. So this final answer that I wrote at the bottom would probably be a preferred final answer rather than having the negatives, but at this point, both would be fine. And then finally for part C, we have to do some work. Because inside the square root, we have numbers that we can actually do. And inside the square root, we have more than one A. More than one A there. For the B's, is there supposed to be a number there? There's supposed to be a little 3. It just, oh, it got cut off a little bit. So there's a 3 there. Okay. So, I am going to, so that we can see this really well, I'm going to take a picture of that question, move it to a new page. Maybe. I hit a button, bother the computer just a little bit. Still waiting for it. Have a little break. Look at the question, prep for it. Oh, there's it. There's the button. I'm going to take this question, move it to a new page so that we can see it. This is where your mental math comes in. Do you see that 32? There's a perfect square in there. Okay? There's actually two different ones that would work. 16 and 2 and 4 and 8. If possible, you always want to choose the bigger one. So I see 16 and 2. The square root of 16 is 4. So that means a 4 comes out in front, giving me a 12. Okay? I think you'll make less mistakes in total if you can do more stuff with mental math. Okay? So I see that 16, that 6 square root of 16 is a 4. That means I bring a 4 out in front. That 4 hits the 3 out in front, making 12. Then I go to my variables. I have a to the 5. Every time you have two a's, you can pull one out, because the square root of a squared is a. Can you see if you have a to the 5? You can pull out an a once there, another a once there. So I can pull out two a's, leaving me with one inside. So I'm going to pull out two a's. What am I left with inside? I pulled out a 16, that leaves me a 2 inside. I pulled out two a's, which is an a to the 4, leaves me with only an a inside. Okay? This is where it'll take some practice, and our mental math skills have to be pretty strong so that we're not making mistakes as we go through. If you want to check, you can say, okay, this a squared would be an a to the 4 inside of a square root. That would give me a to the 5 inside the square root. I think my a's are correct. Okay? With the 12, if I wanted to keep a 3 out in front, that means I'd have a 4. Square root of 4 is 16. 16 times 2, 32. It matches up. Next one, minus 45. Mental math, you have to see which number 45 is. 9 times 5. I can, square root of 9, I know. So that means I can pull out a 3 in front. 3 times 2 is 6. I have b cubed. Means I can pull out a b in front. What am I left with? I'm left with, pulled out a 9. That would leave me with a 5. I pulled out a b. That means inside, if I had 3 b's, 2 of them get grouped together to pull out 1. I'm left with 1b inside. Plus 125. It's 25 times 3. Square root of 25 is 5, so I can pull out a 5. 5 times 5, 25. With a b, I just have a b. I can't do anything else with that. But I had a b out in front. That b stays out in front. What am I left with? After I pulled out 25, I'd be left with 3. Oh, sorry. I'd be left with 25 times 5. I'd be left with 5b. Okay? And finally, minus 72. 72 gives you options. Mental math, it's 9 times 8. It's 4 times 18. And it's 36 times 2. 4 is a perfect square. So 4 times 18 seems like it should work. 9 is a perfect square. So 9 times 8 is better than 4 times 18. But 36 is also a perfect square. So 36 times 2 is our best option. Okay? And again, look at the mental math we have to do. We have to see 72 and be able to break it up into a whole bunch of things. In particular, we're looking for the biggest one. So 36 times 2 means I can pull out a 6. 2 times 6 is 12. I have an a cubed, which means I can pull out one a. There was an a out in front already. Gives me a squared. And what am I left with when I took out the 36? I have 2. I took out 2 A's, leaving me with just 1 A left. Okay. I am not mad if you added absolute values here, because when you pull out a b squared, normally you should have absolute value of b. Okay? It's not necessary in this situation because the defined part already told us b is positive. So since b is already positive, putting absolute value bars around a positive number is redundant. Right? That's a great word. I love the word redundant. It means you're overdoing something you didn't need to do. Right? So, do we have any like terms? This blue box is identical to that blue box, and this purple box is identical to that purple box. So we're going to have, those are like terms. 12 minus 12, love it, 0. Negative 6 plus 25, that is going to give me positive 19 b, and I won't put the absolute values because we don't need it, it's redundant. 19b square root of 5b. Question?
So when would you use that?
So if you just had this, and wanted to simplify it, this is defined for everything, which means that your a's could be positive or negative. But when you square root something, the answer is always positive. So now, here we're dealing with abstract. When we see it with real numbers, we see why. If I had the square root of bracket negative 4 squared, your order of operations would say, oh, you should square negative 4, and then you would get square root of 16. What is the square root of 16? It's positive 4. The square roots are always positive in the end. But if I just canceled out the square and the square root, which is what you're tempted to do here and just write a, then my answer would equal negative 4, which isn't right unless I put absolute value bars around it, making it positive 4. So the reason we have those absolute values is because when we square root something, the answer should be positive. And 99% of the time, you'll just write a. In fact, your math teachers, including me, later on in more complicated questions, we're going to be like, don't worry about the absolute value. We'll be lazy sometimes, and we'll just be like, it's just a, right? And we can do a bunch of math, and everything works out. But there's this tiny little bit saying, well, if a happened to be a negative 4, like here, and you just did that, you would get negative 4 as the answer, which is slightly wrong. So we have the absolute values there. In fact, so common, and I have to blame myself and other teachers, so common is it that teachers don't worry about the absolute values that a professor from university said, here's a list of the most common errors that high school students come into university with, and this was listed as one of them. Because we so often just say, it doesn't really matter. We can still do all the math like we wanted to without having to worry about that. So, but it is a common mistake.
Well, if you don't provide what was that sign again?
Absolute value
Yeah.
signs? Mm-hmm.
If you don't put the signs on the right tabs, do you get right the marks off?
It depends on the situation. Then sometimes, like, if you had this and we're simplifying, you need the absolute value. Okay? So, if you want to be safe, whenever you absolute value something squared, if you put the absolute value bars, even though here I said it's not necessary because of how it's defined, if you put it there, I'm not going to take off extra marks because you're redundant. Okay? Questions for practice on this one, circle number 8.